In this video, I am going to discuss section 6.5, solving polynomial equations. So, a polynomial equation is an equation that contains a polynomial expression. The degree of a polynomial equation is the degree of the polynomial. We have already solved polynomial equations of degree 1. Those are the form ax plus b equals c. We are now going to solve polynomial equations of degree 2. A polynomial equation of degree 2 is called a quadratic equation. Okay, so let's look at some examples of quadratic equations. X squared plus 5x plus 6 equals 0. Another one would be 3y squared plus 4y equals 10. 64u squared minus 81 equals 0. Another one would be n times the quantity n plus 1 equals 42. So these are all examples of polynomial equations of degree 2 because the degree of the polynomial is 2, okay, and we call these quadratic equations. The general form of a quadratic equation is ax squared plus bx plus c equals 0, with a does not equal 0, okay, because then our x squared term would be gone. And a, b, and c are real numbers. Okay, now we're going to talk about the zero product property. Okay, so the zero product property states if a times b equals 0, then either a equals 0 or b equals 0 or both. So we will now use the zero product property to solve a quadratic equation. Okay, so I have a quadratic equation, 5n minus 2 times 6n minus 1 equals 0. So there's my quadratic equation. Okay, I have a binomial times a binomial, and it's set equal to 0. All right, so using the zero product property, we know either this equals 0 or this equals 0 because the product of these equals 0. Okay, so we can set each factor equal to 0. Okay, so the product equals 0, so at least one factor must equal 0. then we will just solve for n in each equation. So I'm solving a two-step equation, okay? I need to isolate n by itself. So I'm going to use inverse operations. And now all I need to do is divide by that 5 and get n equals 2/5. Over here with this equation, I will add 1 to cancel out that -1, and I get 6n equals 1. Now divide by 6. Whatever you do to one side, you have to do to the other, and I get n equals 1/6. Okay, so n equals 2/5 or n equals 1/6. You can also check those by plugging them into your original equation and solving. Okay, so we are going to solve quadratic equations by factoring. This quadratic equation was already in factored form. Okay, but say that I give you the quadratic equation 2y squared equals 13y plus 45. All right, so the first thing we need to do is we need to write it in standard form. So we are going to get 0 there on the right side of our equation. So in order to do that, I need to subtract the 13y and the 45. Whatever I do to one side, I do to the other. Okay, so these cancel out. That gives you 0. So I have 2y squared minus 13y minus 45 equals 0. All right, then we're going to go ahead and factor. That's our next step. Then we will set each factor equal to 0 and then solve each linear equation, and then we can do our check. All right, so in order to factor this, I can go ahead and use that MAC method where I multiply the 2 times that 45. So if y squared minus 13y minus 90 equals 0. Okay, now I'm trying to think of two things that multiply to give me a negative 90. And then add to give me negative 13. Well, I know this term and this term have to multiply to give me that first term. So I have y times y gives me the y squared. All right, we're getting a negative product, so we know our signs have to be opposite. So I'm a positive and a negative. It doesn't matter which one you put where. Okay, then we can start thinking of our factors of 90. So you can try a few different ones. Obviously, if you do 45 times 2, the difference of that is not going to give you a negative 13. Okay, so then you need to start thinking of some other numbers. Okay, so you can do all right, 18 and 5, which also will give you a difference of the negative 13. Okay, so I can go ahead then and know that my 18 is going to be with the negative because that's the sign of the middle. So that's going to go here. And then I have 5 here. Okay, because negative 18 times positive 5 does give me negative 90. And then they add to give me the negative 13. Okay, well, I'm using that MAC method. I multiplied by the 2, so this is where you need to come back and divide by that 2. Okay, so when I go to simplify this, I move my denominator out in front, so I have a 2y plus 5 times, here this will go ahead and divide to 9, so then I have y minus 9 equals 0. Now I can take each of these factors and set them equal to 0. And then solve each linear equation. So I have 2y plus 5 equals 0, and y minus 9 equals 0. Using inverse operations to solve the linear equation, I'm going to have 2y equals a negative 5, and then divide by that 2. So then y equals a negative 5 halves. And here I just need to add 9 to each side. So I get y equals 9. Okay, so y equals 9 or y equals -5/2. And you've just solved a quadratic equation by factoring. Okay, so the first thing you have to do is you need to write in standard form. Okay, so that's that ax squared plus bx plus c equals 0. And then you're going to factor. So we went ahead and got it in our standard form. Here we went and factored our quadratic equation. And then you're going to set each factor equal to 0. And then solve each linear equation. Okay, and then you can always do that optional check after that if you want to by just taking each of your solutions and plugging them in there to that original equation and making sure it makes a true statement. Okay, so let's go ahead and look at another one just for chuckles. Okay, let's go ahead and solve 2d squared minus 5d equals 3. Okay, so our first step is to go ahead and get it in standard form. So we need to have 0 over here on the right side of that equal sign. Okay, so I need to subtract 3. Whatever I do to one side, I have to do to the other to keep my equation in balance. So this gives me 0. Okay, sorry, it's a little windy. So I have 2d squared minus 5d minus 3 equals 0. Okay, so you can use the guess and check method, all right, because we see that our leading coefficient is not a 1. So we're either going to have to do guess and check, or we can use that MAC method like I just did on the last one. Okay, this one wouldn't be too bad to do guess and check because we don't have a lot of factors for either of these numbers here, okay? So that is up to you. Using that MAC method, you do multiply that leading coefficient by our constant. So now I have d squared minus 5d minus 6 equals 0. Okay, so now I'm trying to think of two things that multiply to give me a -6 and add to give me -5. Okay, so once again, I know that my signs have to be opposite because I'm multiplying to get a negative. And then here, the first term, these multiply to give me this. Okay, think about FOIL. All right, so my factors of 6 then, I have 1 and 6, okay, and we see that that's going to be the numbers that I use. So I put the 6 here and the 1 here because I end up with a -5. So 1 plus a -6 does give me -5. 1 times a -6 does give me that -6. Okay, but I use the MAC method, so don't forget at this point to go back in and divide by that 2 that you multiplied by. Okay, I don't want this fraction. Okay, so I move the denominator out in front. So I have 2d plus 1. This will divide to give me 3. So I have d minus 3 equals 0. Okay, so it is now factored. And you can always check your factorization by using FOIL or the distributive property to make sure it gives you this original equation, okay? So you could go ahead and multiply. This would give you the 2d squared, and then if we do our outer, that is a -6d. Our inner is a positive 1d, and we combine those to get the -5d. And then our last terms are the 1 and the -3, which that product does give us the -3. Okay, so our factorization is correct. You could also just skip all this and just do that guess and check method where you know this times this has to give us this. Okay, and our only factors of -3, they're going to be, well, the only factors of 3 are going to be 1 and 3, and you know, one has to be positive and one has to be negative to give you a -3 product. So it's just a matter of figuring out which one is going to go with which beginning term. Okay, so we've done our factorization. Now we're going to use that zero product property and set each of our factors equal to the 0. Because the product is 0, that means that one of the factors has to be 0. When we multiply and we get 0, then that means one of our factors are 0. So we go ahead and set each of our factors equal to 0 and solve the linear equations. So I have 2d equals -1, and then divide by 2. Whatever I do to one side, I have to do to the other. So I get d equals a -1/2. Okay, here I have a one-step equation to solve, so all I have to do is add the 3, and I get d equals 3. Okay, so d equals -1/2 or d equals 3. Those are my two solutions, and I can check by plugging them in here to my original equation. So you would plug in the 3 for the d and solve and make sure it makes a true statement, and then you can check your -1/2 by plugging it in for that d and making sure it makes a true statement as well. Okay, so those are our solutions. We just solved a quadratic equation. All right, let's go ahead and do another one. Okay, so I have 36x squared equals 121. First thing I need to do, remember, is go ahead and get it in that standard form. So I'm going to go ahead and subtract 121 so I can get my equation equal to 0. Whatever I do to one side, I have to do to the other. So I have 36x squared minus 121 equals 0. Okay, now I see that I have the difference of squares, so I can go ahead and use that difference of squares pattern. Remember, a squared minus b squared equals a plus b times a minus b. Okay, and I have the two perfect squares. All right, so my a squared is going to equal the 36x squared. So that means a equals 6x when we take the square root. And we know 6x times 6x gives us the 36x squared, okay? And then here I have b squared is 121, so that means my b equals 11. So when I get a factor, I'm going to have the 6x there for my a and the 11 there for my b. So this is going to become 6x plus 11 times 6x minus 11 equals 0. So I have factored that quadratic equation, and now I can go ahead and set each factor equal to 0. Okay, 6x plus 11 equals 0, 6x minus 11 equals 0, and then solve the linear equations. We'll just use those inverse operations so that we can get x by itself. So I have 6x equals a -11. And I need to divide by 6, running out of room. Okay, so I get here, x equals -11/6, okay? All right, and now, so that's one of my solutions. Here, I'll go ahead and solve then this other linear equation. All right, so I'm going to add 11. So I get 6x equals 11, and then divide by 6 and get x equals 11/6. Okay, so those are my two solutions to this quadratic equation. All right, now, let's say that we have just k plus 1 times k minus 1 equals 8. And I want you to solve this quadratic equation. Well, in order to use our zero product property, one side of the equation must be equal to 0. And here we do not have that. Okay, so the first thing I need to do is get this equal to 0. Well, we need to multiply this out and find that product, so then we can subtract 8 and combine like terms. And then we'll factor that. All right, so I can go ahead and multiply this out. Okay, so I'm going to have k times k to get k squared. You could also notice that we have conjugates here. Okay, so you could use that pattern. Or you can use the FOIL or distributive property. I'm using FOIL. All right, so when I combine like terms, those are going to cancel out. So I get k squared minus 1 equals 8. Now, in order to get my right side equal to 0, I will subtract the 8 and then subtract 8 from the other side to keep my equation in balance. So this does give me 0. Here I'm going to have a negative 9 and I have that k squared. Okay, so I have the difference of two perfect squares, so I can use that pattern again. That a squared minus b squared equals a plus b times a minus b. All right, so I take the square root of this and it goes in my first spot. Okay, so that's going to be a k and a k. We have a positive and a negative, and then take the square root of this term, and that goes here and here, so that's going to be a 3. Because the square root of 9 is 3. Okay, so I have factored. Now I need to set each of these equal to 0 and solve those linear equations. So k equals a negative 3, or k equals positive 3. Okay. All right, so I want you to go ahead and try some of these. This is section 6.5, all right? And we'll go ahead then and do 283 through 311 every other odd. All right, so practice some of those on your own and just message me if you have any questions. I have the study guide up there in the files section, and then I also have the answers to the study guide there in the files section in Canvas. So take a look at those, go over that study guide, and then test will be Wednesday at our normal time, 10:45, only we're going to be meeting in the library. And I'll have some more videos up for what we were going to cover on Thursday, and then hopefully we'll be back in the classroom on Monday. I hope everyone has a great rest of your day, and just let me know if you have any questions. Thanks.